Right, so here we're going to look at software and software development part 3, I think, which is software development. So understand the waterfall life cycle and all the other ones, and we'll go through it as quick as possible. So software development is the process of analyzing the problem that you are solving, then preparing and creating a solution. So let's say a company comes up to you, they're a sports center, and they want a system to track all their members and what they do and all this sort of stuff. Probably some sort of database with a front end to it. So you would go through the analysis, design, implementation, evaluation, and maintenance stage. Now, they're not always the same as these. This is like sort of general ones of what's called the system lifecycle model. But most of them go through this kind of similar process. Might be some prototyping in others, but essentially it's similar. But we'll go through those later. So analysis. Here you first define the problem that you're trying to solve. And it's very important that you get this right, especially in some models, which we'll look at later. Because if you get this wrong, all the rest will go wrong. And in some of the models, I mean, you don't really get a chance to go back to this. So you kind of get to the end and hope that you got it right. So yeah, you need to look at what the system needs to do, what it might need to do in the future, and what does the current system do? You look at that. And then you would, these are the things that you would actually, how you would do that. So you need to create sort of a document, really, like a user requirements document. And inside it, it would have these things: what the system should do, what the current system does, what data is needed, what's going to happen in the future, how will you deal with errors and other issues, okay? And here's how you would find that information out. You could interview staff, customers, observe the current system, look at documentation and various other bits. So that's the analysis stage. You would look at the system that's there already, look to improve it. What about the future? Talk to staff, talk to customers, talk to clients, talk to everyone. And then you'd write what's called a user documentation or user specification. Sorry, system specification or user requirements. But these words get flipped around: system requirements, user specification. A document that essentially is your requirements, right? If you go online, you'll find 28 different names for what this document is. But basically, it's a list of the requirements of that you do. So after you've done the analysis, you then create this design. So the processing, what processing will need to be done? Any data structures could be defined here. So sort of tables, layouts, classes, whatever. Some of the input and output screen designs might well be done here, and any major reports. If you've got a security thing that needs to be looked at, this is very important to include here. The hardware requirements, have a look at the current hardware they've got. You've got to look at the hardware they'll need. And then you create some sort of testing plan to test it afterwards, okay? So this is a really, really, really important document. These two are kind of merge into one in my mind. But anyway, and most people who actually do the job sort of, because like you analyze and create at the same time. You don't do all this and then create that. Like you do a bit of this, edit that, you do a bit of this, edit the design document. But the point is, if you look at it this way, it's what you do. Make a big analysis, create a final design structure document, whatever you want to call it. And then, this is really important because this document's going to be sort of part of your evaluation. When you're testing, you're going to look at this document. So you really need to make sure this is right, because otherwise this won't get right. And if these two aren't right, then the rest don't really matter. Because even if you do a good job, you're doing a good job compared to your design, and your design is wrong. And your design is wrong because your analysis was wrong. So these are all very important things to do early on, especially in some models, because there are models where after this stage, there'll be no more user input. The person asking for the software won't see it until the end. So if you've got it wrong with them, then, they're going to get something that wasn't what they wanted. So then, of course, you go into implementation on installation of the software or the system. So you create the code, you write out technical documentation. So remember that. Obviously, installing the software to the machine as well as any hardware, you get everything ready. Obviously, that'll be very specific to the system you're installing. And then you go on to testing. Yeah, lots of fun at testing. And there are 4 types of testing we're going to look at: black, white, alpha, and beta. So black box testing is done without any knowledge of the code. Data or tests are generated from the user specification, so from the document you put there, to cover all inputs and outputs. So it looks at what the system should do with data coming in and what it should produce coming out. And it does and creates test plans to test for that. But it doesn't do it by looking at the code. Right, so that is part of the issue. So this is a little bit better. The reason you have to do both types of testing, it'll be important. It'll come apparent in a second, and I'll tell you. So white box testing is done using the code logic. So you literally look at the code and you test all code paths or branches. So if there's an if statement, if greater than or equal to 100, you do 100. You do 99. You go through every path of that code and check that it does exactly what you said. But one of the issues with just doing white box testing, which is very good, but it doesn't test for parts that are missing, because obviously if you didn't do something in your design and you implement it, they can't test it. Whereas with black box testing, that's going to find that, hopefully, because it's going to look for, you're going to say, right, apparently I can enter in this data and get out this data, and you haven't implemented that, so I can't do it. So, do it. Whereas here, you're just testing what they've made, not whether it meets the design documents. So they're sort of, they work together in team, because this will test like every situation, inverted commas, because you can't test every situation, but it will test for like most unlikely situations that might get missed. Whereas this will test for the most sort of common things that will happen, because it's looking at the actual design and what it should do. Then you've got alpha testing, which is done in-house by the software developers, and it looks at the user requirements to find gaps. This is just more sort of usage. But yeah, so this is a type of testing done in-house, and it looks to find gaps in this document. Okay, right, it's trying to see if this design document is correct. And the beta testing is where, you know what that is, you probably use beta software in your life, where they release it to the public to be tested, and the public can, report any bugs and errors, like in real life, common usage. I know I'm saying that that's what they do there, but they can only do that so much. Like what you think is common usage might not be what an actual user thinks it's common usage. And, you don't know, maybe you're not a specialist in that field. You might not be an artist using a paint program. So you tried all the things you were going to do, and then a real beta tester comes and goes, no, we use this and it broke. So yeah, this is releasing it probably to the public, or some customers specifically selected, and then yeah, they would test it. So obviously then you go on to evaluation, which might have some sort of review of the final product, and it'll look at it'll evaluate how well you've done based on how well the system matches that system specification, user requirements document, whatever you want to call it. So that's why it's important to get it right, because otherwise you're going to evaluate yourself as a success, but you didn't actually do a good design document, so this is not really going to work. So the 3 types of maintenance you would do after the evaluation is corrective, which is the one you might think of, which is fixing any bugs found even after testing, as it always happens. Adaptive, which is where the user requirements are likely to shift and change, so we need to add or alter things. Okay, they're going to say, oh, we want this to do it now, we want that to do it now. Very common. You may have if you're doing this in the real world, you may have a contract and they have to pay you a certain amount of money or to pay you to do these things, but depends on the contract, so don't get too caught up on what I just said, because you're not worried about the contract part of it. And the last is perfective, so you're just trying to make it better. And you improve the system anyway, more functionality, optimizations, making things easier, making the user interface better, things like that, things that, sort of superficial things, or maybe not, but, like basically things just to improve the system. So now we go through the different methodologies of it. These are a bit long, so I'm going to whip through them, but obviously you can pause and come back. So the waterfall model works like this. Okay, very similar to one I said before, and each stage is completed and documented before moving on to the next one. You might go back up in the waterfall model, but you do tend to go down. Once you go down, you don't tend to go back up, although you can. You tend to go down to the end. The customer has very little input after the initial analysis and only sees the product at the end, which means that changes often mean the whole project or a lot of it has to be restarted. So this is one where you sort of see the customer a lot here, go away, you make the system and come back, and they look at it and hope it's right. Okay. So the advantage is easy to use. There's separate, well-defined stages, and it's quite good for small projects with well-understood requirements as changes require restarting. So if you really know what a system's likely to be like, and you might, because you might have made 1,000 other systems very similar, then this isn't a bad model. But there's no early prototype, which I think is really important. I don't like this system at all. The lack of user involvement means that if we get the requirements spot on, we really must do. But the thing is, what you sometimes don't understand here is that the user doesn't always, like, they think that things are obvious, or they imply things like they'll assume the system would do that because the system I use always does that. You're like, you didn't say that, so I didn't do it. So you have to be very careful, because the client might not 100% know what it actually needs to do. They only know what needs to come out of the system, and sometimes that doesn't involve a lot of back stuff they don't understand. And if the final product is wrong, then it's often too late to change. They're the disadvantages you need to know of that model. So there's something called the spiral model. Look at my very attractive spiral. This repeats, by the way, but I couldn't be bothered to keep writing them. Keep going in and goes on forever and ever. So the idea is you go around through much short steps. You quickly whip through, back around, rather than sort of doing a really big analysis, followed by a really big design, followed by this, followed by this. You do sort of quick, and you keep going back around. Analyze, design, implement, evaluate. Analyze, design. So there's a faster pace between steps, allowing for re-evaluation. It creates a very early prototype, which is great because then you can show it to the customer. And everything is always about the next iteration. So what I mean is when they say analyze and design, they're not trying to design the final product, just the improvements they're going to make on the next model that's going to get one step closer to perfection, closer and closer to. I quite like this one. It's quite easy to manage, and obviously you get an early prototype. There's lots of feedback, and the customer often gets a product they're more happy with because obviously they've had far more input into it. And it's easier to add new features because essentially every time you go through, you can add new features. The problem is, and this is why the companies don't like doing it, it takes longer and therefore costs money. And it is probably better on larger projects, although personally I like it anyway. Because I find, but don't write this down in the exam, but I find on larger projects, people tend to know their requirements more. And on smaller projects, people tend to know the requirements less. But we'll see. I mean, that might just be my limited experience with actually performing this. Personally, like and system. Anyway, it is what it is. So, spiral method. Then you've got the agile method, which is very similar to the spiral method, if I'm being clear. But yeah, I mean, it's very similar. The difference is here is that rather sort of creeping towards a better product, here it produces high quality code each time. So they're not trying to sort of just produce a very quick rubbish prototype. They're trying to produce smaller parts of the system that are very good. So it rapidly goes through the cycles. Building on, by the way, that's typo, previous versions. There's less planning and lots of testing. Okay, so they sort of test it a lot. Yeah, and it's good for products with an important deadline. So that's the important. If you need a really important deadline, Agile's quite good. So if you Google Agile method, you find that many people hate this method. But this is an exam we're going to talk about. So just look at the stuff on the screen. Spelling error version should be on. I'm just going to change that live in case there's any subtitles. It's going to sure it's obvious. So yeah, I mean, if you Google Agile method, you'll find that developers hate this method. But there we go. So the advantages are that lots of rapid delivery to customer means lots of feedback. It's normally faster to produce software, and it's quite adaptable as feedback is constant. But less early design can lead to missing parts, and that's the thing really. It's less early design. It needs an experienced team, and if the customer doesn't fully understand the system, they need the project. Then the project may fail. But that could be true for all of this. But try to just remember these because this is what the exam boards say. I'll be honest with you. If you Google these, you'll find that a lot online people talk sort of differently about some of the advantages, disadvantages. Some people say that Spiral was very good on small projects, but these are what you got to learn. So there you go. Okay, so you just got to remember these. So the last two to look at are quite quick ones. The extreme programming is a type of agile, so it's very similar to this one, but they frequently release the software, so it's released out to be tested, and this is quite good when the user requirements may change a lot. Okay. Anyway, last one is rapid application development, which is where there's loads of focus groups and discussions to gather quickly rather than documents. So rather than documents about discussions, lots of prototyping, and they use time limits on each part of the system. So you're only allowed sort of like 2 weeks to produce this, and they try to reuse software from. I mean, look, with all of this, you can get from my tone and delivery that this is kind of a lot of project structure and as a developer in the past, you can get more like managerial stuff. So in the end of the day, you need to know it for the exam, and this is what you need to know. In reality, the real world, models will be very flexible based on the project. No one necessarily sticks to these very structured. I have heard people using the agile model and the spiral model as a workplace, but they're not as rigid as this makes it out to be. I mean, like each company will do. But for you, you just need to know what all these things mean because you need to pass the exam. There you go.